There we go. I'm going to forget it's running. There's no indication that we have on my side that I'm recording anything. There's nothing that blinks or anything. Anyway, there we are. We don't have a very long day, but it's kind of a hard day. We're going to talk about normal probability plots. So a normal probability plot is a graphical technique for assessing whether or not a data set comes from a normally distributed population. The ordered data are plotted against where they would lie in a theoretical normal distribution. If the data came from a normal distribution, the points should form an approximate straight line. Departures from the straight line indicate departures from normality. The details of the procedure are pretty much outside the scope of the class. We'll see some details. The actual derivation of the process is fairly recent, in the past 50 years. Using these techniques to assess normality is kind of new, and the actual details of it are even newer than that. So it's kind of close to present day statistical procedures, what we're going to do here. And we're going to look at some examples of histograms, and then we'll look at these probability plots. Then we'll learn how to make the plots, and we'll learn how to assess if they're close enough to, it's supposed to be a line, close enough to a line. Departures from a straight line indicate departures from normality, so we're about to do that. Here we go. So I've got a histogram here. And then there are a lot of values, because this up here, this says there's a 10 here, right? So maybe there's, does it say? N is 60. Right here, 60 values. Ordinarily, when there's that many values, you probably don't care if something's normally distributed or not. We'll see that there's something called the central limit theorem that says if you look at the sample mean, if the sample size is large enough, the sample mean has that normal distribution we want. And if the sample size is small, then we have to be careful that the data is normally distributed. So ordinarily you wouldn't bother doing this, but here's a picture of one where the sample size is 60. So just so you can see the pattern. So there's a clear curve here to the shape of the probability plot. And we said it's supposed to be like a line. It's supposed to stay within these bounds here and be more like a line, and it's just not. So not close to the line. The bounds aren't present on every computer printout. This is one kind of software that's called Minitab, where it gives you those confidence bounds where you're supposed to, the dots are supposed to stay more or less within those bounds if you think the data was normal from a normal distribution. So not close to the line, so the data might not come from a normal distribution. That's what things look like. If it's skewed to the right, we'll see a curve like this, where it's turning to the right. But we don't care too much. We just say it's curved, so the data doesn't come from a normal distribution. End of story. Okay, did that. And then here's some other data here. This stuff here came from a normal distribution. So here's more what things look like. So that histogram looks sort of bell-shaped. It's sort of hard to read histograms. So what people do is they do probability plots, because that gives you it's easier to see a straight line than it is to see a bell curve, I guess. So here the data is pretty well perfectly linear. The same number of values, 60. Those are all close to the line, so the data may have come from a normal distribution. The histogram will be approximately bell-shaped, and there it is. So we're going to see how you can make these probability plots without all this fancy stuff on it, because this came off of Minitab. We're going to use our calculator because it does it. So we're going to do that right now. Here we go. I have some data. There it is. And we're going to enter that into the calculator. I don't think I stuck it in there, but I hope I did. I was playing with it earlier. I don't remember, though. So clear this. Go stat, edit. I have other stuff in there. I'll just clear this out. There we go. And then now put in I guess I'll just stick it in here. 10, 12, without thinking. that working? Kind of. Okay, so let's see. It says, did I miss one? It says it's supposed to be, did I forget the 10? What's going on here? Get up there. So according to this, there's 12 values. So there's 12 there, over here. And so I see downstairs here, there's a little 12 in here. That says that's the 12th value. So that's nice. The 12th one is 32. And I go up to the top again, take a look. So 10, 12, 14, 16, 17, 19, 21, 24, 28, 37, 45, and 32. There it is. Okay. And so I want to make a note here. Data is in L1 like that. And then we're going to make a normal probability plot. We're going to use stat plot to do it. So we go second stat plot. We go ahead and if we scroll here, we can select different plots. Plot 2 is on. I'm going to go into it and turn it off. I'll push enter. I don't know what it is. I'll just turn it off. Okay, and then I'll come back up here. Back to plot 1. Maybe I just go back to stat plot, make sure everything's okay. Second stat plot. Okay, now all the, I could have gone down here. That might have made more sense. Go to 4 and turn all the plots off and start over, but they're off anyway. Okay. And I guess there's only 3 available stat plots. I've never paid much attention, but I saw the menu on top there. You pick one of the 3. So I'm here in plot 1. Okay, so I'm going to hit enter and turn it on. And then come down here and pick type. It turns out this guy all the way on the right is a normal probability plot. It doesn't tell you, but that's what it is. So we select that. We come down here to the next item. It's in, the data is in list 1. Then it says, which side do you want the data axis to be? So if I want it to look like these graphs here, we've got, these are the data values on this axis. And these are the predicted positions on that side. So we take a data value and we look at its value and we predict where it should be. The scale here is nothing we can figure out at the moment, but that's not the real scale. That's been rescaled in a different way. We'll see what it looks like in a minute. Okay. So if we want it to look like that, we'll make the data axis the x-axis and we'll pick a mark. That's good. Go down here. Okay, so then we did all that. And then to look at the graph of that, I have to hit graph. So we finished all that stuff, nothing happens. I hit enter, 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 nothing, nothing, nothing. It's kind of annoying, but you go to graph. Okay, I'm in graph now. Again, nothing happens because probably the graph window is set wrong. So I'll go to window. I don't go to window. I go to quit. I go to zoom. There we go. I should know, we're on zoom. And we scroll down to zoom stat, that's there. What that'll do is set the window based on what's in the stat plot data sets. Okay, there we go. And then we get that. Okay. So that's looking pretty straight. If you want to see what the values look like, you hit trace. And you can use your arrow key to move along. So 10, I can't really read that. Maybe I should zoom in a bit harder. Let's see what it says. Come over here. Yeah, for 10, the y value is negative 1.73. And then as we go along, so these are the z values that would, like the smallest value in that size of the data set should be about minus 1.73. That's what that says. We'll see how to get those in a minute. And then 1.15. And we get to the middle, it's going to say the z value. There's 12, so there is no middle. I see. So we're at 6, it's negative. We're at 7 is positive, and the rest of them are positive. And so we can see it here. There's where the graph crosses the y-axis, the x-axis when y is 0 there. So 6 of the values are on each side of that. That makes sense to me. Okay, so that's what it looks like. And you would say, well, it's reasonably straight. It's a little bit curved to the right. As we drive down there, we're making a little bit of a right-hand turn. So maybe slightly skewed right. And you go, oh, yeah, it might be slightly skewed right. I'm looking at it here. Looks skewed right. But is it bad enough? And so here's a strategy we're going to use. So here we go. Still here. Let me back this up so I can not look at this so hard. Okay, there it is.
I'm able to back up for a sec. I put all the info in. I went second stat plot. I turned plot 1 on, and then I'm not for sure what to do.
You have to go to zoom here and go down to zoom stat. So that'll set the window based on the data.
Okay, I got zoom and then 9.
Yeah. They hit enter there, and that'll set the window, and then you have to hit graph again. How are we doing?
Well, yeah, I got my histogram, and now I'm trying to hit the graph, and nothing's happening. Yeah, well, whatever.
It didn't happen, no? What do you have? Let me see what you have.
I got this.
You got to hold it. Oh, you're looking at a histogram.
Yeah.
I don't want to do that. Can you turn that off?
Well, I don't know how.
How'd you turn it on? Oh, here, stat. I know where it is. Watch this. Second stat plot. Plot's turned on. You come down one step. Over there is histogram. See it? You've got it selected at histogram.
Yeah.
Come over here to the end. That's where a normal probability plot is.
Okay.
Then hit enter.
Oh, okay, gotcha. Yeah.
Then hit graph. Everything will be fine.
All right, gotcha.
Did it work?
Yep.
There it is. It's magic. So that's all fine and dandy, but there's something more we want to do. Be sure to stop me if you can't get it to work, because I can't see what's happening on your calculator. Okay. So we're going to, I hit trace, and it showed some y values that go with these. The negative, I'll keep zooming and crying. Here we go, zoom in again. Where am I? Yeah. So that negative, I'll go back over. So that smallest value, it's z value that goes with it. The 10 is the smallest value. And the smallest value in a set of 12 numbers that are from a normal distribution, from a standard normal distribution, and in fact, would have a value on average of minus 1.73. And so we want to see how to compute that. So we're going to do that. The 1.73, here it comes. I think. Struggling here. There that is. And you know what I'm going to do? I'm going to stop